Question 16. We are given a quadratic and that's x squared plus 10x plus 36. And we're told that that is identical to x plus a all squared plus b. The completed square form. A and b are constants and we're asked to find the value of a and b. So we need to complete the square. Halving the linear coefficient, subtracting the square of that, and then tidying up. Minus 25 plus 36 gives us 11. So we have completed the square and we found that a equals 5 and b equals 11. The question then goes on to ask us to show the equation has no real roots. In order to show that the equation has no real roots, normally I would jump straight to the discriminant. And I would take b squared minus 4ac and show that it was less than 0 and therefore there'd be no real roots. But the question says hence, and it doesn't say or otherwise. It specifically wants me to use this. So let's think about how we would use that. If we're looking at roots, we're making it equal to 0. Let's do that now. If I subtract 11 off both sides, which would be my process for solving for x, my next move would be to square root both sides. We can't square root a negative number. Well, not and get a real solution. And imaginary numbers are not something we're looking at just yet. And that effectively shows why we cannot get any real roots. However, this is an unusual approach. Normally you would do this by looking at the discriminant. So as a side note, I'm just going to go through how I would do that. b squared minus 4ac, the discriminant. In this case, it's going to be 10 squared minus 4 times 1 times 36. If I evaluate this, this would give me 100, and this would give me 36 times 4 would be 144, so I'd end up with minus 44. Since this is negative, the discriminant is negative, or more generally, the discriminant is less than 0, therefore no real roots. The reason I remember that less than 0 means no real roots is because if it's less than 0, negative, inside the quadratic formula, it would be being square rooted, and that's the same problem that we had here. This is a more general solution to the question, show it's got no real roots. In the question we were asked, it said hence, which specifically means we needed to use this part here. Hence, I followed the working through on that method. But in most cases, the discriminant would be the method that you'd want to use. But not in this one. This was just a side note. So continuing on to part C. In part C, we're first of all told that the equation x squared plus 10x plus k is equal to 0 and has equal roots. And we're then asked to find the value of k. X squared plus 10x plus k equals 0. And it's got equal roots. Equal roots, therefore, b squared minus 4ac equals 0. If we substitute in the values a, b and c into this, we're about to solve for k. b is 10, b squared is 10 squared. A is 1, c is k. Simplifying, I probably could have made that 100, couldn't I? Well, I'll do that now. Dividing both sides by 100, k is 25. And that is how we've solved to find k, based on the fact that we were told there's equal roots. We knew the discriminant would be equal to 0. We substituted in, using the values from the equation, and solved for k. In part D, it says, for this value of k, sketch the graph of y equals x squared plus 10x plus k, showing the coordinates of any point at which the graph meets the coordinate axes. So, let's start with the equation. X squared plus 10x plus 25, and that's our, well, it will be when it's equal to y, that's our equation. If I want to find the y-intercept, this is the expanded form, so that's clear there. The y-intercept is at 25. In order to find the x-intercepts, I need to make this equal to 0, and I need to factorise it. Now, once I've factorised it, I can see that this is going to give me a repeated root of x equals minus 5. This means that it will intersect with the x-axis at minus 5, but not cross it, just touch it. I can also see that this will be a positive quadratic, this point here will be 0, 25, and this point here will be minus 5, 0. And there's my sketch. Question 16 complete.